Hello, and welcome to today's webinar on the topic of open and interoperable augmented reality. My name is Christine Perret, and I'll be delivering today's session for you. I want to thank the IEEE Standards Association for hosting today's webinar. This presentation is part of a series of IEEE webinars designed to inform and raise awareness about augmented reality topics in a vendor-neutral way. Today I'll be sharing with you the concept of open interoperable augmented reality, how it differs from current technologies, and how some organizations, including the IEEE, are reducing barriers to open and interoperable AR by building upon standards and filling gaps. Some of you watching this webinar may already be familiar with some of the technologies, such as distributed computing, radio technology, and geospatial industries that have similarly been based on open standards, and they've become part of your daily life. For example, when you use Wi-Fi, you're using technologies that conform to the specifications developed in the IEEE Standards Association. Over the next hour, I'll be explaining why AR currently relies on closed technology systems. Then I'll define the concept of open and interoperable augmented reality and describe some of the activities that are changing the landscape. The business benefits that are produced as a result of lowering the reliance on proprietary systems will depend on where you are in the ecosystem. In the past, large ecosystems develop more quickly and with greater diversity than when they are based on open systems and standards. In the second half of this webinar, I'll be describing the current status of activities in standards groups that have recognized the potential for augmented reality. Before I get started, I want to go over a few housekeeping items and let you know how you can participate in today's session. If you've already joined today's webinar listening through your computer speaker system, also known as Voice over IP, then this means you'll be able to hear the presentation without dialing in. If you'd like to use your telephone, just locate the audio pane and select Use Telephone. The dial-in information and access code for today's session will then be displayed. You have the ability to ask me questions using the WebEx chat feature. Simply type in your question to our host, David Stankiewicz, and click Send. At the end of the presentation, David will get to as many of your questions as possible. So let's go ahead and get started. I'm an independent consultant, and I've been studying augmented reality. That's at the fusion of, at the intersection of space and time. So I do research, and I try to help to better understand the technology and business landscapes that people use in augmented reality. Try to understand these communities and to develop where there are gaps and where there are needs, new initiatives. I also organize and chair communities that work on different kinds of problems, and I provide consulting services to my clients based on this technology and business landscape that you see before you. The IEEE Standards Association is very interested in people's awareness and being able to use augmented reality in the future. That's why they have helped to put together this series of webinars, and I encourage you to go back to the past webinars and the recordings, which you can consult either on YouTube or on Google+. Our past episodes include introduction to augmented reality and a variety of topics such as how companies invest and spend money, or the use of augmented reality in cities or in manufacturing. I think there's something there for many people. Today, though, I'll be focusing on open and interoperable AR, and I'm going to be giving you a little bit of an update on augmented reality in 2014 as we approach the end of this year. I'll be giving you some definitions and talking about why people might want interoperability in augmented reality, and then I'll be giving you some details about standards organizations working in this domain and share with you where we're going in the future. So let's take a look around at augmented reality this year. what have we got? Well, we still have the physical world. It's a wonderful world we live in, and there's a growing number of digital assets. And if you take these together, the physical world and the digital assets, you can apply them and create augmented reality experiences for specific use cases. What you do is you choose one of the many, many authoring tools that are available today, and there are over 100,000 developers that have gone this route. They've downloaded some type of a software development kit or got a login for a web-based service so that they can experiment and make their own AR experiences. With these, they hope to reach and to communicate with many, many people that have AR-ready devices. Now, what do I mean by that? I mean they have sensors and they have all of the technologies to detect the context of the user and to display the augmented reality experience in context with the real world. That's called AR experience delivery. So while there may be up to 1 billion people who have these fast processors and heavy sensor-rich devices, very, very few of them are actually using it. Well, let's take a look first at the landscape of companies that have been working in augmented reality over the last 5 or 6 years. And you'll see that on this slide is but a very small number by comparison to the full potential. We have hundreds of companies that are involved in some way, thousands of developers that are actively using augmented reality. So if we have, let's say, several thousand augmented reality developers that are responsible for, they are responsible for most of the experiences. So this is a typical long tail scenario. What we mean by that is that there are a few killer applications or a few people who are very skilled at making augmented reality experiences and do this full time, providing a great deal of value to their clients. There's another group, maybe another 10,000 or so developers, I'm not sure, several thousand developers that are responsible for yet more experiences, but they individually account for a smaller number of augmented reality experiences available. And then we have the typical scenario where the vast majority of those developers that have expressed interest in AR have only made a few AR experiences and are probably not spending a great deal of time thinking or working on these topics. Similarly, I mentioned before that in 2014, we may, at the end of 2014, have as many as 1 billion smartphones with the sensors and graphics accelerators necessary to produce AR experiences. But unfortunately, a very, very small portion, maybe 10%, maybe less, are actually using mobile augmented reality on something of a regular basis. So while many of us are enabled, still very few of us are users. So why is this situation? What is missing between the early adopters and getting to this early majority? This is a classical picture that you've probably seen before describing the chasm between the early adopter and the early majority. So the question we have is, what's missing? What exactly needs to be done to fill the gap? Well, first of all, many more people need to be trained and have the skills to build AR experiences as well as to use them. So we have a lot of education to do. And furthermore, augmented reality experiences are very expensive to make. Even if you do have the skills, you'll spend a lot of time and you'll need some special licenses. So what we would like is perhaps to have more automation and to integrate the workflow producing augmented reality into other workflows so we could reduce the cost and increase the quality of those experiences for the end user. And if end users were able to open AR on any device, if those devices were interoperable, you could open, just like you have today, the situation you open a web page with any browser, it's pretty likely to work. We need interoperability, and we need extensions to existing systems that we have. So how are we going to go about getting all this? Let me introduce you to a few of the concepts that many of us are working on. what is open and interoperable augmented reality? I say that it's a set of values, or perhaps you could say it's a school of thought, a practice that we hold in order to advance the development of a complete end-to-end system in which modular components can be supplied by a lot of different vendors. And from the user point of view or the developer's point of view, they have the same workflow and they have an experience quality that they've come to expect. So I say that in this box, it's hard to say, is it gas, liquid, solid? Is it half full or is it half empty? Well, those are all questions we can wonder about later. First question is, how can we get away from the proprietary technology silos that are so common today and get more companies involved in open and interoperable systems? So towards this goal, we can define that when we get there, we will know that the whole world remains a very, very exciting place on which to do augmented reality. You'll be able to choose any digital assets, and you'll be able to use a wide variety of AR experience, authoring tools, and workflows. Because they'll be easier to use and more available, more affordable, more developers will have access to these and the skills and desire to author the experiences. Because there'll be more experiences, there'll also be more end users. So they'll be kind of floating around in this sea of content, let's think, and that they will be able to use their devices with some standard compliant software to open and experience those AR experiences. Well, what are some of the benefits of this thinking this way and working towards this end goal? Will permit us to have more consistent content and technology management. And if you can manage content and technology better, then you can probably integrate it more easily into your existing systems. Interoperability is going to simplify the developer's authoring, publishing, and integration tasks. Interoperability will also help users. It'll simplify the way they discover content in the real world, how they share it with their friends or colleagues, and how they consume it in their daily lives. So if we could agree that that is the end goal and some of the benefits of getting to augmented reality that's open and interoperable, where would you rather start? It'd be analogous to saying, well, I want a house and I'd like it to have windows and doors and all of these interlocking parts. Where should I begin? And I think rather than starting with raw materials and primitive tools, what we should do is build upon our existing standards and use modern tools and modern ingredients, modern materials that are made to go together. So with this in mind, there's been several hundred people over the last 5 years working together in a grassroots community towards this goal to have open and interoperable AR. We bring together standards development organizations. Sometimes I'll refer to them as SDOs. And we bring them together with augmented reality developers so that they can discuss where they see opportunities and where they see obstacles. As part of this community, we operate a web portal, and you can find it at arstandards.org. We also have archived mailing lists for different task forces and projects. We conduct virtual meetings and in-person meetings, and I hope you'll attend one of those depending on your level of interest. We've done some pretty fantastic things in the time that we've been working together. The initiatives that we've completed, just a few of them, are to have a cross-SDO collaboration to make augmented reality 3D compression and transmission easier to get from the source to the destination. We've also developed an AR interoperability architecture. And in the picture on this slide, you can see where you have 3 different browsers, that of Wikitude, Layer, and Genio, all looking at the same real-world content and having the AR experience superimposed starting from the exact same bits. So this interoperability, browser interoperability was very important over the course of 2014, and this has now been released in the commercial platforms of these three companies. We also have developed some resources, and we have, for example, a table on our website with all the relevant standards you might want to look at, also some developing standards, emerging standards, and the activities of the standards development organizations. We have a calendar of meetings, a glossary of terminologies, and we also have, we've been working together on the mixed and augmented reality reference model. The target audiences of the mixed and augmented reality reference model are four. For example, we think that there are the technology providers. They need to communicate with the experienced developers as they have been doing in the community, but they need to do that in an easier, smoother way. And the end users could benefit from this reference model if they could communicate what they want in a consistent way. And the standards development organizations are the fourth target audience. If the technology providers and the developers can use the reference model, then they'll be able to improve the communication, and they'll also be able to develop new business models where, by better understanding who they're buying from and who they're selling to. End users will benefit because there'll be more experiences in total, but they'll also work on many more different hardware and software platforms. The reference model is also valuable to standards development organizations by helping them to understand where their existing standards are relevant, where there are gaps, not only in their own standards, but also between standards development organizations' domains, and then each one can focus on the new work necessary to achieve open and interoperable augmented reality. The mixed and augmented reality reference model proposes a system architecture that I show on this slide. So the system starts certainly with the physical world, and the user is in the physical world. There are sensors that are detecting the conditions in the context of the user. The user has an interface and a display. And within this box, this rose-colored box, is the scene, the recognizer, simulation, and rendering engines. And these make use of media assets and other external services. Now, this describes only what happens during the detection of the context and the delivery of the experience. We use the same system architecture to define three viewpoints in the MAR reference model. One of these is called the enterprise viewpoint, and it defines the roles of different organizations, from the end user down to the telecommunications operator, the content creator, the content aggregators, and a variety of different middleware providers. The AR reference model also describes the computational viewpoint, and in this case, it's the different components that contribute to the functionality that we see in the system architecture. So just for example, the box called the MAR execution engine includes the renderer that is connected to the display, and the user interface is connected to the simulator, which has the event mapper and the spatial mapper. So you can see that while as each time we go down a further level in detail, we get more specific terminology. There's also an information viewpoint that defines the formats and the data types that enter and are outputs of the different components. We can see how it's used in this slide. The mixed and augmented reality reference model can be used to map implementations to this abstract architecture. So in this case, the SK Telecom AR browser architecture is in the lower right-hand side, and we can map the different components to the system architecture and the component viewpoint. This has been very helpful to define and to discuss business relationships that SK Telecom has with developers and other partners. These are some of the examples of the work of the AR community to date. We've had about 12 or so different standards development organizations either come to us or be the topic of presentations during our meetings. Now, we anticipate that there are many other standards organizations and industry organizations that have relevant activities and that we could fill in these holes in our figure. The most active standards development organizations are the International Organization for Standardization, Khronos Group, the Open Geospatial Consortium, and the IEEE Standards Association. And as you can see on this slide, I've identified some of the areas that they are promoting. And I'll be talking about those in more detail in the next section. Let's begin with the Khronos Group. The Khronos Group has been working to develop royalty-free APIs to connect software to silicon. And it's really been a very productive collaboration. There's over 100 companies working in this standards development organization. We can think of 4 different areas that are relevant for augmented reality. Starting in the upper left, there are some visual computing specifications, OpenGL and OpenGLES, and OpenCL, that are for graphics and to help the software access the silicon for heterogeneous parallel computing. In the upper right, the Khronos Group is responsible for Collada. That is a 3D asset interchange format. And then more recently, they have a 3D asset transmission format, which I'll be explaining to you in more detail in a moment. Many of the Khronos Group standards are valuable for those who are using the web. So the acceleration in HTML5, as you can see in the lower right-hand corner, helps to accelerate OpenGL and OpenCL. Those are both used in HTML5, and that way you can have faster performance for many of the things that we see, such as maps. Finally, a new group of standards being developed in the Khronos Group over the last few years is the OpenKCAM, OpenVX, and Stream Input. All 3 of these pertain to sensor processing. In the case of OpenVX, it's already been released. I'll tell you a little bit more about it in the next slides. But these are highly relevant for augmented reality as well. In this figure, you can see how Khronos APIs can be used in augmented reality. The acquisition of context permits us to synchronize the sensors together using EGL for precision time stamping. The sensors, the observations from the camera can be managed, and better camera control can be achieved using OpenKCAM specification. The stream input in the middle of the screen defines how the sensor data enters sensor fusion or the sensor hub. OpenVX defines how the video stream is processed. And all of these go together and are combined into the accelerated experience using better chips and signal processing. I'll now dive in a little bit further into the GL transmission format, or GLTF. It's a runtime asset format for WebGL, OpenGLES, and OpenGL applications. It permits a much more efficient use of the hardware, and there's little or no data that's dropped when you get to the client application. This is a relatively new specification and new work, and the Khronos Group is prototyping the standards-based pipeline from Collada to the WebGL feed playback. This is how you can think of GLTF and Collada within the larger ecosystem. You start at the top with the ability to import and export content, 3D models, from the tools from which they're made into the interchange format. So there's tool interoperability provided by Collada. Then, using the Collada to GLTF translator, you can then use the GLTF files or the Collada files and other authoring formats and put them to transmit them more quickly and in a compressed manner to the client application. And here you can import the content, it could be, or you can export it, and then use it through your web browser. Pervasive WebGL deployment is very important to the proliferation and the widespread use of WebGL. And then these are integrated into many of the web-based tools for creating 3D models. Now let's take a closer look at the vision pipeline. This is very important to augmented reality, as I already mentioned, starting with the ability to control the camera. There are many, many different kinds of cameras today. You may have heard of depth cameras and camera arrays, stereo cameras, and all of these are unpredictable. They are more and more available, but the developer of software doesn't know if the user has them. So by using OpenKCAM, the software developer will be able to write to the API to detect the latest hardware and software. The video that comes from that camera or the still image can be processed using OpenVX. This support for diverse vision processors allows the different silicon vendors to specialize and to demonstrate their unique value, but all the while accelerating the processing of the video signal. The video signal can be combined and reused with a variety of sensors that tell us about the orientation of the user, the sounds from the microphones, maybe haptic sensors, and other sensors that are continuously providing us with insights into the user's context. And these all are fused with the video to provide a better experience. This is a little bit more detail on the OpenKCAM specification. If you are interested in more information about this draft specification, you consult the Khronos Group website. And here's a little bit more information about OpenVX. It's a power-efficient vision acceleration specification I've spoken about a moment ago. And this has also already been released in the 1.0 spec, and there's going to be more coming soon. Stream input is available, is only in draft, and there's many people thinking about how they can use it to perform better context acquisition and better AR experiences. Now let's talk about another standards development organization called Web3D Consortium. Web3D Consortium is responsible for X3D. That is the second generation of the virtual reality markup language, but now it's been designed for the web. So it combines file formats that people are familiar with already, and it puts it together with a runtime engine, or what we call a player. And so now there are a variety of different proprietary and open source players, and this helps us to have better 3D experiences on the web. There are a range of X3D profiles. They go from the core profile to different other applications. And the goal really of this is to make it available regardless of the complexity and the resources, the computational resources that are available on the platform. A lightweight X3D version is using the scene graph rendering system, and it is complementary to other runtime systems that you're already familiar with on the web and on mobile platforms. By having X3D profiles, it permits the developer to reduce the reliance on scripts, protos, and high-level sensors, and accelerates the use of X3D on mobile applications and in web pages, and for augmented reality applications, of course. X3D 4.0 is under development. It's going to have complete HTML5 integration, and it's going to permit it'll have an open source JavaScript player in it, and it'll support WebGL and Flash. There'll be no plugins required and available in the 4 most important browsers. So certainly go check that out if you have interest in 3D augmented reality. Another standards organization that I'd like to speak with you about is ISO Subcommittee 29 Working Group 11, otherwise known as MPEG. MPEG stands for the Motion Picture Experts Group. MPEG has been standardizing specifications for over 25 years. You may be more familiar with the MP3 format for audio and the MP4 format for video. There are also many other video compression algorithms. It's a very, very active group. They have over 500 experts that meet quarterly and many hundreds and thousands of others working separately and together. They have a protocol for the way they develop standards, and they have been very successful. And so we think that that's something that's relevant for us all. MPEG has been working on components that lead up to augmented reality. But the vision that MPEG has is that there would be an authoring tool using the real world or the digital representation of the real world, and this would produce a scene and an application together, as you can see, using, if possible, MPEG-4, MPEG-7, MPEG-21, MPEG-U and V specifications. And this would all be compressed and downloaded to the MPEG player. Using these different prior established MPEG specifications, they have all been defined in something called the Augmented Reality Application Format. ARAF, as it's called, is an end-to-end chain. As you can see, it sits between the authoring tools and the user. So the ARAF definition of the scene and the player produces then an ARAF browser, which can access media and other services that are in the cloud. There are 3 components of ARAF, or sometimes they can call it MPEG-A Part 13. There's a set of scene graph nodes, or protos, that are defined in Part 11. Some of these are familiar to us, audio, image, and others, but some of them are new. User interactivity, for example, and new protos such as camera collaboration, map marker, overlay, and other necessary components for an augmented reality experience. In addition, the MPEG ARAF spec defines how the sensors and actuators are used. Actually, those are all defined in MPEG-V, but it uses those interfaces and definitions as part of ARAF. And then it also defines how to compress the media and to package that with the runtime engine. The ARAF browser, there is an ARAF browser available today already for the iOS operating system, Android, Windows, and Linux, and it's open source. Earlier this year, ARAF version 1 was published, and now they're working on version 2. They're adding visual search, 3D audio and video, access to social networks, and other commercial point of interest services. Now let's talk about the Open Geospatial Consortium. The OGC has several standards for augmented reality. In fact, it has more standards for AR that are relevant to AR than appear on this screen, but I'll only be talking about these for today, and I invite you to visit the Open Geospatial Consortium website for more information. So the OGC stands for Open Geospatial Consortium, of course. However, its work is not limited to the geospatial domain. ARML, or Augmented Reality Markup Language 2.0 Working Group, was based in the OGC. It developed a candidate standard. It is available for a review if you'd like to take a look at that. There are several organizations. I think there's up to 50 organizations that have participated in the working group, chaired by Martin Lechner. The basic idea of ARML 2.0 is that you have assets that represent something in the features of something in the physical world, and those anchors are in the physical world. So you have the digital asset, and you have the features, and they are connected by the anchors. Could be a marker, it could be a place, it could be a 2D or natural feature recognition algorithm. But the total of this workflow from the right to the left is the production of an augmented reality experience that uses the real world. The current specification is, as I said, available for review. There are already some implementations available. We used ARML 2.0 as the basis for an interoperability interchange, for an AR interchange format that was the basis of the AR browser interoperability test that I mentioned earlier. In addition, the AR browser that I mentioned earlier as well, developed by SK Telecom, is based on ARML 2.0. There should be a vote later this year, and then it would be widely adopted. Well, geospatial data can also be called, or it's attached to, points of interest. And several years ago, the W3C began a points of interest working group, which gradually merged and in collaboration with OGC got moved over to the OGC Standards Working Group to finish. The use cases are that there are people who have points of interest that they maintain themselves, or there may be points of interest aggregators that are offered as services. And there would also be consolidators that gather points of interest, and these would be brought together in an open specification, Open API. Another OGC specification is called GeoPackage. It's a geodata file format that is self-describing, that is independent of the application or the platform, therefore highly compact and highly mobile. It allows you to download and to store different kinds of data onto the mobile device and then to interact with those as if they were in the cloud. When reconnected, those data in the trails and the metadata of that interaction then gets reconciled and synchronized in the cloud. OGC is also working on indoor location. The Indoor GML specification defines how the indoor modeling is depicted, and there are also the definitions of indoor venue maps, indoor positioning, and they have a collaboration with the In-Location Alliance, with whom they have many members in common. Indoor GML is derived from City GML, which was provided many years earlier. The City GML provides different levels of detail, some of them defining space, some of them defining the perimeters or the walls, and other lower levels of detail defining the sensors and other areas in between. So Indoor GML and City GML have a lot in common, and they are already in use, and you'll see and hear more about that in the near future, I'm sure. In the OGC 3D Portrayal Services Working Group, they're defining how different models, 3D models, can be brought to the mobile device depending on the resources that are available. In some cases, it may be better to transfer the whole model and to have the scenes selected once it's on the mobile device. In some cases, in other cases where there's very low computational power or low bandwidth available, you may want to have only images transmitted to the viewing client. And so the 3D Portrayal Service defines an interface so that you can choose between these different ways of handling the 3D city models. Another standards organization that I've mentioned before and is responsible for our webinar today is the IEEE-SA. The IEEE-SA is working on market education and awareness programs, many including this webinar and others that we've spoken about. You might recall that we presented to you the scenarios for AR in 2020 project. That's an example of one of the activities that the SA is working on. The SA is also reaching out to the standards chairs and editors to help them discover new use cases that include augmented reality so that they can support those in future work. The IEEE-SA helps disseminate information about standards and how open and interoperable augmented reality can come about, and to demonstrate domain-specific uses for AR. There'll be many more programs. You can find out more about those and stay up to date on the website. It's part of the Innovation Spaces area on the IEEE-SA website, and as I mentioned, covers the AR for scenarios for AR in 2020, as well as all the information needed to access the archives of the AR in your future series. There's a list of current standards projects and standards and projects that are relevant to AR, and in the future, you should go there to look for white papers and other resources. The list of standards that's available on that site was developed using 6 impact areas. The IEEE-SA examined their standards and projects using these impact areas and identified the key standards and projects. And now those are the basis, and these and other tools are the basis for additional work. The IEEE has many hundreds of thousands of members, and they can be clustered into some of the vertical markets that are most important and most relevant to augmented reality. For example, in health and wellness, we could imagine that the medical practitioner may use augmented reality. The consumer may want to use augmented reality to be better tuned into their heart rate or their other significant data. And we can also perhaps envision augmented reality in many other use cases in emergency management, the planning and operation of power and electrical systems, transportation, and learning technologies or learning systems. Those are some of the things that I wanted to share with you about the different standards organizations that are working actively to bring about open and interoperable augmented reality. You may also want to do some research on open source augmented reality. I always like to point out to people that interoperability can be achieved by many different ways, and one of them that's very common and easy to understand is through standards. In addition, there are and there could be in the future more open source alternatives. You should be thinking about how you can participate in this activity towards leading towards open and interoperable augmented reality. For example, you may want to participate and join in the new AR Industry Connections program at the IEEE. You'll be hearing more about that because they'll be doing education and market awareness programs. They'll be writing and speaking about the use cases and the vocabulary so that people can have realistic expectations that can be met with the technologies available. So you should be able to join that soon. In addition, the AR community continues to meet. We continue to introduce augmented reality in more new domains. For example, the construction and architecture engineering domain, or perhaps medical visualization, and to introduce more standards development organizations to one another. This coordination activity also involves developers and content providers. We have virtual meetings about specific programs. For example, we've had a recent meeting on the subject of the reference model that I spoke of earlier. We've also had a recent virtual meeting on the topic of AR discovery. On the week of November 24th, we'll have another meeting on the subject of the AR glossary that you may want to join. We continue to have in-person meetings. Our next one will be in March 24th and 25th in Cambridge, Massachusetts at the MIT Media Lab. Well, I hope that I've explained to you that augmented reality is something that currently relies heavily on proprietary technology silos. And as long as this is the case, it's going to be very difficult for the developers to reach their potential because they have to learn so many different tools, so many different interfaces. It's difficult to integrate augmented reality into today's workflows and for people to find augmented reality when it's confined to the technology silos. Open and interoperable augmented reality is more than just some specifications. It's more like a school of thought. It's a set of principles that we aspire to and that we hope the ecosystem will build upon. We can begin with the existing standards, extend them where possible, and find the gaps that need to be filled along the way. The activities of the standards development organizations that I described to you today and the grassroots groups are very important to the success of open and interoperable AR. I think the coordination helps to reduce overlap and to help us find the areas of complementary work. And there remains a great deal to do to educate developers, technology providers, and the end users to the use of augmented reality and the adoption thereof. So that's all I have for today for our presentation component. We have about 10 minutes left. David, have there been any questions that I can answer?
Thank you, Christine. We did get 4 questions from the audience, so thank you everybody who participated in today's session and asked a question. Christine, I do want to ask you a question first. I did get 3 or 4 comments now about your slide deck. I know that you own the content and the deck is proprietary. People are not only interested in the video, but your slide deck as well. Can you address that before we jump into Q&A?
Sure. Thanks, David. This particular presentation has been accumulated, or it's composed of contributions from many standards organizations. So these slides are available from the standards organizations themselves. That's one source for this material that I've shared. I realize that it's very dense, and there are many of the slides that have a lot of detail. And believe me, this is the very, very condensed version for today. The information that's available about open and interoperable augmented reality is also very well documented on the arstandards.org web portal. So the status of all the SDOs when they come to our in-person meetings are updated on that web portal. So I really think that that's the very best place to begin on this particular subject. This slide presentation is very heavily based on the content that's on that portal. And I think it's also important to note that people can contact me directly and share with me what their goals are. I'd be happy to discuss and to share my presentation with them individually.
Perfect. Thanks, Christine. Let's jump right into the Q&A. Our first audience question: is augmented reality connected to the modeling and simulation communities and/or the standards development organizations? For example, the Simulation Interoperability Standards Organization.
Very good question, David. Thanks. Yes. Well, CISO is one of the standards bodies, one of the organizations within the IEEE. And so, of course, we're very interested in speaking with them about the use cases. As a matter of fact, as part of the IEEE's outreach activity and evangelism for augmented reality, we have just conducted a meeting with the working group chairs and the editors of CISO specifications. We identified those as being very important because of the interaction between the user, the real person in the real world, of course, and the digital data. We think that there are very relevant applications in the military, in Air Force, and training, and Army, Navy, and other services. And we are looking into how to extend what they already do as part of the distributed simulation standards I think that's the 1278 family, and definitely want to encourage those who are in simulation to look into augmented reality and better understand how you can reuse some of the assets, especially some of those 3D models that have been created for virtual reality. How can those be reused in augmented reality scenarios? So if we can better define the real world or its digital representation, we can make more accurate experiences. Very, very good and fertile area. Someone's thinking along the lines we are. Thank you.
Okay, moving on. Question number 2. How will patents be impacted by open and interoperable augmented reality?
Well, it's very exciting times in many fields, and people are protecting their intellectual property with patents quite often. Some people are concerned that there would be patents that they're using when they create augmented reality experiences. As long as you license the software development kit, that's your protection. But for open and interoperable augmented reality, we think this is going to benefit the holders of patents as long as they are outside the specifications. Although there are some cases in which intellectual properties are written into a standard. It is common, it does happen, in which case then the specification needs to be paid for, or there are some royalties that go to the owners of those patents. We think that today there's very little precedent for patents in augmented reality. The question is, are there specifications that could encroach on future patents? In this area, it's really up to the patent holder to declare that should it be brought into a specification. So that's part of the terms and conditions when working in a standards development organization. You have to disclose what you're putting into the spec. It could be that there is inadvertently some intellectual property that's included, and this is something that standards development organizations are very experienced with and do take all steps to clarify prior to publishing. So this is a very, very important difference between a standards-based approach to open and interoperable AR compared with using grassroots or de facto standards that could be based on patents that later they tell you you need to pay for. So we think that interoperability based on standards will be very, very important for the future viability of open and interoperable AR.
Okay, Christine, let's address question number 3. Can you speak to open source AR projects? Are there any?
Right. I did mention that very briefly, so I'll be happy to follow up. There are probably a dozen open source AR projects. Some of them go back 10 years. But the most important today are connected to geospatial mobile augmented reality. And in these cases, the projects have very few supporters, so they're looking for more developers to participate. And this is an ongoing issue. The exception to that, I know that there are 1 or 2 projects that are based on visual augmented reality or computer vision-based AR that are open source. And you can find those by looking at some of the directories of SDKs. There's a comparison of SDKs that has quite a good listing of open source projects. And I think that this is an area that has not yet really flourished. There's going to be more activity in this area in the future and very little significant work being done on it today.
Okay, Christine, the fourth and final question, and then I will let you wrap us up here. Thanks again for everybody who joined today's webinar and those who asked questions. The final question that comes through for Ms. Perret is, do I need to be an IEEE member to benefit from OpenAR or get involved in OpenAR?
Great opportunity to say that the IEEE is an open organization, and you don't have to be a member. Of course, there are many benefits of membership, but participating in the AR Industry Connections program or to benefit from the educational and awareness-raising projects such as this one, it's not necessary to be an IEEE member. I would like to encourage people that if you have an interest in this area, you can become an IEEE volunteer. It's a very important role and one on which the IEEE relies very heavily, and it's one of the keys to this organization's success is the dedication of its volunteers. So if you have interest in augmented reality and you'd like to work more on this, first go look at the Industry Connections program that's on the website, the IEEE web presence, and then introduce yourself to the staff liaison for augmented reality, Mary Lynn Nielsen. So if you have any questions, do get in touch with me and I can put you in touch with the proper folks leading up these different initiatives. Thank you very much. This concludes today's webinar presentation. Tomorrow, the discussion about this topic is going to continue. Join us for the next episode in our AR in Your Future series on Friday, November 14th at 11 a.m. Eastern. The IEEE Standards Association is hosting a live Google Hangout panel discussion about open and interoperable AR. We'll have a panel of experts representing the SDOs I've described today. They'll be discussing the trends they are seeing and how they support the objectives of their members. It should be a very lively and engaging discussion, even if it is about standards, and it's entirely free. So please tune in tomorrow and watch our Google Plus Hangout. For more information on viewing sessions in this series, visit the IEEE Standards Association Google Plus page. Thank you again to the IEEE for giving me the opportunity to bring you today's webinar, and have a great day, everyone.